We swipe our phones and stream movies, completely surrounded by the illusion of a weightless, floating cloud. But beneath that seamless software is thousands of pounds of heavy, physical hardware sitting in freezing server rooms. Fresh out of the box, these millions of dollars of networking machines are completely dormant. They are chaotic and blank, with no sense of who they are or where they belong in the broader system. A company can spend a fortune on highly advanced software firewalls to protect their data. Yet, if a malicious actor walks into that cold server room and plugs a cable directly into the physical control panel on the back of a switch, they bypass all of those expensive software defenses instantly. This diagram shows the required first step to stop that exact threat. Before any software security can do its job, an engineer has to physically connect to the hardware and lock down this foundational layer. True cybersecurity always begins at the bare metal, inside a physical room. The software cloud relies entirely on the locks we put on these heavy iron boxes. To turn a blank machine into a trusted part of the network, the very first step is giving it a unique name. You are giving the physical machine a digital name tag so the rest of the system can identify it. Looking at the access control section of this graphic, engineers set encrypted passwords that act as digital deadbolts. This ensures that even if someone physically touches the device, they cannot change how it works without authorization. But the hardware has a critical flaw. Its standard memory operates exactly like a goldfish. If a power cord is accidentally bumped and the machine loses electricity for even a millisecond, every password disappears completely. Engineers solve this by saving their work to permanent memory, or NVRAM. Think of it like writing your instructions in ink instead of on a whiteboard. Even if the power cuts out, your security settings don't wash away. Building a secure perimeter is useless if it relies on a continuous electrical current to exist. Writing those parameters to a permanent chip is what actually bakes the identity into the hardware. Once the device is secured, we run into a logistical problem. Network administrators cannot spend their entire careers walking down to a freezing server room with a laptop every single time they need to check a piece of equipment. They solve this by assigning the switch its own digital address. This creates a secure backdoor so the engineer can manage the equipment remotely from a warm desk. This glowing map illustrates how devices know where to send data. If a digital address is a specific house, the subnet mask is the boundary line drawn around it. It tells the computer where its local neighborhood ends and the broader network highway begins. Even with an address assigned, the physical ports on the switch remain asleep. The networking industry uses a default deny rule, keeping hardware turned off so a stranger can't just plug in a laptop and instantly join the network. To bring the ports online, the engineer types a command called no shutdown. It is the digital equivalent of walking into a dark basement and throwing a heavy breaker, allowing raw power and data to finally surge through the fiber optic cables, illuminating the previously dark network. The hardware only becomes a functional part of your network after it is both logically mapped to an address and explicitly awakened. With the environment powered up, engineers use a command called a ping to verify the connection. It is the universal heartbeat of networking, a tiny pulse of data sent across the cables, asking a simple question: are you there? This verification graphic shows the path that pulse takes as it travels between two computers on a newly configured network. When you send that very first pulse, a fraction of your data intentionally fails. Instead of a perfect connection, your screen shows an 80% success rate. Network switches can't read the digital street addresses used in software. They only recognize the unique hardware fingerprint stamped directly into the machine, called a MAC address. It's tied to the physical metal. This creates a missing translation step. The sending PC knows the street address it wants, but it doesn't have the hardware fingerprint it needs to complete the delivery. Software addresses are useless for moving data without a final layer of hardware translation to bridge the gap. This is a lookup process called ARP, like a digital shout-out in a crowded room. The sender hits pause, asking every nearby device for the hardware fingerprint matching the target street address. That very first pulse dies waiting because the digital handshake takes a split second too long. Once the correct machine replies, the sender saves that fingerprint in a local memory table. With the translation saved, the second attempt bypasses the lookup. The data fires instantly, connecting with a perfect success rate. This exact same invisible handshake repeats across every inch of the global internet, operating constantly right under our noses. Every streaming movie and secure message you send relies on data flowing through thousands of physical switches, all using these exact foundational handshakes. Mastering the basic rules of physical hardware gives you the blueprint to understand the entirety of our modern digital world.
Okay, students, now we're going to go into the next packet tracer. Okay, this is 2.7.6 packet tracer. Implement basic connectivity. Now, we're just stepping it up a little higher. Remember, we still working on basic configuration. We're not going away from that, but we're going to work a little bit more. We're going to put some more talent into this, give you some more configurations. Okay, so in this, just to give you a little background, in this particular packet tracer, you know that you will be first creating a basic switch configuration, then you will implement basic connectivity by configuring the IP addressing on the switch and the PCs. Then the IP addressing configuration is complete. You will use various show commands to verify the configuration. So right here you see addressing table, switch configuration, switch management interface, PC configuration, verification and testing. That is critical. You must do that. And then I'm going to give you a cinematic view of the whole demonstration. And at the end of this, I'm going to actually demonstrate the packet tracer for you like I've been doing. So as you can see, in this particular level, we're going to deal with switch 1, switch 2, PC, IP addresses, and then the subnet mask. Okay, once we get through with that, of course, we're going to go ahead and start putting host names on, passwords, banner. You know how to do these things already. You already know it, but we're going to make sure that we consolidate this so we can keep practicing. As you can see. Okay, now, then we're going to come out of here and we're going to go do some switch management stuff. This is going to be the first time. This is the new thing. Interface VLAN 1. Put an IP address on it. No shutdown. You know what no shutdown means. Now, if you don't understand some of this, go back to my previous videos. Remember, I want you to like it. I want you to subscribe. And I want you to go back and make sure you know what you're doing. Also, you got PC configuration right here. You know how to do this right here. So the new thing will be consistently making sure that you understand how to do switch management and that you consistently do verification and testing. It's important that you always test your work. Do not do the work and don't test it. It's important. Now, the test tools that we'll be using, of course, is ping, and on the switch is going to be show IP interface brief and show running configuration. These are tools that you should have in your tool belt. Okay, now I want you to watch the entire thing. This was just setting up what we're going to go through, and make sure you pay attention to the cinematic view of things. And then you're going to see at the end where I go in and work on the packet tracer. With that being said, let's go forward.
Okay, students, now that we have looked at the video and we see how everything is played out, let's go ahead and put this packet tracer together. Now remember, this particular packet tracer is 2.7.6. It's called Implement Basic Connectivity. So the first thing I'm going to do is go ahead and proceed to put up the devices. So I'm going to come over here, and of course I'm going to grab me a couple of PCs. I'm going to grab one for there and one for there. I want to change these PCs to PC1 and PC2. So I'm just going to go here and put a 2 in there just to give it a quick name change. And maybe even switch it around so it can look better. So there go PC1, PC2. Now I'm going to grab a couple of switches. So let's go ahead and get us some switches. You know how to do this. You already got this down. I'm going to go ahead and keep working with the 2960, put 2 switches up there. Now, what I want to do here is have switch 1 and switch 2. So I am going to do that here too. Now, this name change that I'm doing right on the switches is really not as affecting the actual configuration. This is just cosmetic right here, guys. So don't think that I'm doing something. Yeah, it will be inside of the switch, but it's basically cosmetics. It's not part of the configuration as of now. So we got that. Now let's go get some cabling set up. The first thing I'm gonna do is follow the cabling. It doesn't look like it has a real cable structure, so I'm gonna create my own. I'm gonna grab this here, click right here, and I'm gonna choose Fast Ethernet 1, and I'm gonna go over here and choose Fast Ethernet 1. Now that's got the switches connected. I'm gonna go ahead again, get copper straight through, and come right here and get Fast Ethernet 0, and come get Fast Ethernet 2. So that's on 2, and I'm gonna get another copper straight through, and I'm gonna go 0 here and go Fast Ethernet 2 here. So we got that laid out. 1 1 2 2. Okay, it looks good. Now we're gonna do the configuration from the PCs. So I'm gonna come through here and get the console cable and click here. Go to my handy dandy 232, click here, console, and then I'm gonna come right here and do the same thing over here. I'm just gonna throw 2 console cables on there so I can make it simple. Now I may not configure this side, but I do have to verify connectivity. So I'm gonna have to go in here and configure the side. So there you go. Now, with that being said, let's go ahead and do some basic configuration. So I'm gonna run through this real quick because it's basic things that I know I can get done really quick. So for instance, the PCs, I'm gonna come right here, go to desktop on PC 1, and I'm gonna put the IP address in for the PC. Now that is 192.168.1.1. So that's the first PC, PC1. And I'm going to tab across there, and that's going to give me this. Now, we're not going to do a default gateway or a DNS server. We don't need that right now. So we're going to go ahead and close this out. Okay, so that's the first PC. And I'm going to show you another trick when you're working in Packet Tracer. This is just a hack trick. You already know it. I can take a copy of this IP address. So that'll slow down my typing. I mean, it's not all that, but every little bit helps, right? So I'm going to go ahead and paste that in there and just make that a 2. So that's the second PC right there. Tab, and there we go. There go to subnet mask right there. Okay, so that's done. So that was a nice little hack trip. So the PCs are configured. Now, we want to throw a few things on here to make sure we get all the rest of it together. So we're going to go back to PC1, and this time we're going to go to the terminal. We see that set up, and then we're going to click here. Now, this lets us know that our bridge is together. So if I hit enter, you can see that right there. Now, what I want to do here is just go right into execution mode. In other words, I want to start configuring this PC. So I'm going to go ahead and go enable. And that takes me to the pound symbol, which you know. And I'm going to say show run. Okay. Now I'm doing this just to show you that it's nothing in here right now. As you can see, it's nothing in here. This is just a hack tip. And you can see that it's nothing in here. Now, nothing is configured in there. So that means we got to go configure. So I'm going to go ahead and just go config if terminal. And now that elevated me to the configuration terminal right there. And then I'm going to say host S1. Okay, now I'm naming the PC. So earlier you saw me do some cosmetics, but now you see me naming the PC, and there we go. And then I'm going to exit up out of here. Go in here and go over to the next PC. Let me jump over there real quick and just basically do the same thing. I'm going to jump back and forward just to keep both of them working at the same time. As you can see, same thing here, enable, config, T, and we just gonna call this, what should we call it? PC2, right? So we're gonna say host name S2, and we got that, and we configured that. So I'm gonna hit that. Okay, so that was simple, but you already knew this. You already knew how to give the PCs their particular names. Switches their names. And that's what we did. You can see right there, when I put my mouse pointer on this, you see S1. And if I go to the next one, you're going to see S2. So we did that. Now, a couple of more things that we want to do. We want to go in here and put a banner on here real quick because it asks for a banner. So we're just going to go in here and quickly throw a banner on. And the reason I'm doing these pieces first, I like to get them out the way, because when you're thinking about this stuff, you don't want to sit up here and keep focusing on things that's really not, that really will slow you down. So I'm going to put banner on here, and of course we're going to do that. And I'm not going to put nothing really in there. I'm just going to throw my name in there real quick. I'm going to put my name. Professor, and I'm put a little period right here. You know what this is supposed to be, so I'm gonna go ahead and do that. Did I spell it right? Of course I did. Okay, and I'm gonna come out of there. So that's my name, but that's just saying we put a banner on there, and you can see I made a mistake right there. So let's do that again. Oh, I made a mistake because I didn't add some. I misspelt the word. You guys didn't say nothing. So BANNER, not ARMOTD. I got to show the mistakes too, guys. I'm not going to hide the mistakes. I'm going to show you the mistakes so you will know. And I could have did it easy by just simply correcting that and not having to type it out again. But now there we go. So the banner is in there, and I'm going to exit. Now I'm going to go over to the next one and do the same thing. I'm trying to do both of these at the same time so I don't make it too long for you. You know how you guys get. You be like, okay, let's bail out. Like and subscribe, people. Don't bail out. But, okay, so here we go. We're going to go config T. We're going to go ahead and put banner. We spelled it right that time. MOTD. And we're going to go do the same thing here. Now, that's supposed to be a security thing right there. That's why we put in the banner in there to secure it. We don't just put anything in there and then we're going to exit out. That covers the banner. Let's see what else we want to do to this. If you watch the entire video, we got quite a few things we want to do here. Okay, so yeah, let's go ahead now and proceed to put the configuration in for the actual VLAN. So let's do the VLAN. So I'm gonna go ahead, come back in here and hit enter, enable, and this time I'm gonna go config T, and then I'm gonna say enter interface. It's supposed to be interface VLAN 1, and I'm gonna go ahead and put IP address because I'm putting the IP address on this particular VLAN, and I'm going to put 192.168.1.253. Now, the biggest problem with putting IP address on the VLAN is some students forget to go 255.255.255.0. They forget to put that in. Then you hit enter, you see it's locked in, and they always forget to do this. So students, be mindful when you typing it in. No shutdown. Okay, that line is up. So let me show you what I just did. The line is green. You see? That line is up right there, okay? And if I put that up, you will see that VLAN down at the bottom, it said line is up. but I have to go to the other side and do the same thing. I want to put the VLAN over here on the other side to make sure that we get that. Let's go in here and do that real quick. Hit enter. And we want to make sure that we put the right IP address on that. Now, like I said, this is where students make their mistake. So we're going to come back to config T, and we're going to say interface. It's supposed to be face, but we're not going to put that in. We're not going to go all the way in. You know, it gets so long. VLAN. And this is going to be VLAN 1, 2. It's the same name, but then we're going to say IP. Look at me messing up. IP address. Oh, look at me messing up. Stop messing up. And then you gotta remember the same IP address, similar to the same IP address, 192.168.1.254. But you have to remember, you must remember to put the subnet mask in 255.255.255.0. If I did that right, everything should go. And it went, and then I want to say no shutdown. Now you know what happens if you don't put no shutdown in. It does not work. Okay, line up. You see it right there. Line up. So I'm gonna go ahead and close this just to show you that this now has, if you look at the bottom, the line VLAN 1 is up. So we configured this. Now it did ask me to put in a password and on the console port and all that. I'm not going to do that because you know how to do that, and we got a lot of work to do. So students, I'm going to cut it off right here because I think we met everything besides just doing a simple check to see if it works. But let's go ahead and do a ping real quick. I'm going to come here to command prompt, and then I'm going to ping. And this is how we check the work. I'm going to ping 1.253. I'm just going to see if I get a ping from there. It's supposed to work. It may not work. We're going to find out, but we can see. Now, you guys know what that first ping means. I'm not going to say anything, but this is what you should put your thinking cap on. Now, if I do that again, I'm going to get 4 pings all the way across. But what do that first ping mean? You saw it in the video. Okay, now I'm going to stop right here because you know from watching this, everything works. And this is the next packet tracer that we did, and we got to remember all these tools. So just to do a real quick recap of this particular packet tracer, we performed a basic configuration on switch 1 and switch 2. We configured the PCs, we gave PCs, we gave them IP addresses, and then we did a basic manage switch interface. So we gave the switch a VLAN. So you learning step by step. Don't forget this information, people. And with that, I'll see you in the very next lab packet tracer. This is Professor Sistrunk.